Two and a Half Admins, episode 63. I'm Joe.
He's Alan.
And I'm Jim.
You can't be both Alan and Jim.
Yep.
I picked first. Live with it.
Anyway, here we are again. And before we get started, Alan, you are going to tell us about the Open ZFS Developer Summit again.
Yes. So the Open ZFS Developer Summit is coming up very, very soon now. You only have a couple days to register by the time this comes out. But make sure to attend. There'll be, if you register, you can join the Zoom and be part of the conference, or you can just watch the live stream on YouTube.
Yeah, that's 8th and 9th of November, so very soon.
Yes, and it's in Pacific time, so it sucks if you're in Europe.
Right. Will it be VOD?
Yes, the videos will be up on YouTube a couple weeks after the conference.
Cool. Well, we'll link to them when they come out. And
the second day is a hackathon, so if you're interested at all in getting started working on ZFS, or even just helping with the triage, the huge number of bug reports in the GitHub, we're planning to have an event for that, so see you there.
Okay, and your blog post is Advanced ZFS Snapshots, Holds, and Clones.
Yeah, so getting into the more advanced things you can do with snapshots, including put a hold on them so that if your automatic snapshot regime normally deletes snapshots after 2 weeks or something, but that one specific snapshot you need to keep, and you can basically put a hold on it, a little lockout tag that prevents it from being deleted until you release the hold. And can be very helpful when dealing with the automation and so on. And then just other interesting things you can do with clones, or with snapshots, like make clones of them to make a writable version of the snapshot, and all the other advanced stuff you can do with snapshots.
Well, links in the show notes as usual. Let's do a bit of news then. The first one is that John Carmack has put out an unlocked OS for the Oculus Go VR headset. This is the first one that's been discontinued now. And this unlocked OS gives you proper full root access.
Yeah, this is kind of the type of thing I'd like to see more hardware vendors do. So basically, Oculus end-of-lifed the low-end Oculus Go last year, and that basically made it a useless brick for everybody who bought one. But with this release now, you can run something at least on it with full root access so that the 2 million people who bought one of these can still use it for something, even though if it's not officially supported by Oculus for their use anymore.
It feels like this should be mandated by governments. If you abandon a product, you should at least open it up so people can hack on it.
Wouldn't that be brilliant? You know, not just hardware either. It would be great if we saw legal acknowledgement and official status for abandoned software as well. You know, there's these abandonware sites all over the web that are the only way that you can play a lot of, classic video games. And technically, it's still piracy and it's still illegal, but they just sort of exist in this weird no man's land where, so far at least, the cops aren't coming for them, so it's kind of flying.
I think especially for hardware, it's even more important because otherwise you're just increasing the volume of the amount of e-waste we have to deal with by just forced obsolescence on these devices. But I agree with Jim that even software and so on, we've just seen this story play out. The efforts over at like archive.org to basically build a version of DOSBox that runs in your browser and so on so that you can play some of these old games, just so that all of this history of video gaming isn't just lost because nobody can make the stuff work anymore. And, we've seen some of the source code for some old games, like I think it was Zork or something, go up on GitHub, but it turns out the source code isn't that useful without all the period tools to actually compile it into a binary that you could run. And, I think some video games will have the same problem of like, sure, we have the source for the video game, we give it away to you, but we can't give you the engine because we just licensed that from somebody else and we don't own it to be able to give it up.
But, TLDR, thank you, Carmack. You did the right thing.
Exactly.
We see you. We appreciate you. Good man.
Hopefully more people will follow in your footprints.
Is it a case of Facebook just appeasing him and letting him do this as a one-off, though?
We know that he had been pushing to do this for years. And one certainly presumes that Facebook, of all people, were pushing back against it pretty hard. But I think part of that equation has to come back to, it's John Carmack. This is not a good little soulless corporate drone that will do whatever the company demands. I don't think I could tell John Carmack no on something that he originally developed and make it stick.
Carmack's tweets are, I hope this is a precedent for when headsets go unsupported in the future, but damn, getting all the necessary permissions for this involved so much more effort than you would have expected.
Yeah, and you'd expect it to be a hell of a lot of effort. So you just can't even imagine how many meetings you had to sit through to get this to happen.
Or just how many people you had to get time with to get their sign off and so on.
Okay, something I found that I wanted to get your guys' take on is HTTPS attestable. And this is some engineers at Intel who have proposed that it's not enough for the connection between the client and the server to be encrypted with SSL. You need to know that nothing has gone wrong on the server side.
The main point of HTTPS is verifying the site you're talking to is actually the site you think it is. So if you're reading this article, the little padlock means that you're talking to the register.com, not just me sitting on the internet between you and them and pretending to be them. And so that now you know that if you're logging into your bank and you're setting your details, you know that that's really your bank. But it doesn't tell you that what's running on the other side of the connection is actually secure. And Intel's idea with HTTP-A is that the other side will provide some guarantee that they're actually processing the information you send them in basically one of these security enclaves.
The way I understand HTTP-A, the whole idea is basically it gives you the same type of guarantee you get from running a signed executable on your local computer, which says that, hey, this code that you're running matches the signature that was given it, by this publishing entity with a well-known signing key. So it's doing the same thing for remote traffic. So you say, hey, well, I know that I'm sending, this confidential data to, intuit.com or whatever, but I want to know that, the script that's handling my data is what it's supposed to be. And so the HTTP-A part is verifying that, it's not just that you're sending this stuff to intuit.com and receiving, replies back, but you're actually having this data processed by the application that you expect it to on the remote side. Now, I do think that this is a worthwhile endeavor. I think it would be a mistake to get too super duper excited about it because you're still talking about, no matter how much you say, oh, well, it's signed code and I can inspect the idea that this data was processed by this signed application on the other end. That's nice, but you're still talking about the fact that the other end has local physical access, right? And what do we say about an environment where the hacker has local physical access? It got owned. If somebody's got physical access out of your site, you cannot guarantee security anywhere. So it's a nice extra step, but I would not really lose any sleep over having that or not having that. It's just kind of another incremental endeavor towards more barriers to throw in the face of, grifters and hackers.
Yeah, I think to carry on your code signing analogy, the HTTP-A seems to be proving that the code that's going to run on the other side is the signed code that you're expecting and not, has been modified to leak a copy of your credit card out or whatever.
But you're just sort of assuming that, whatever hacker you're worried about possibly owning the application servers on the other end has not also gotten access to the keys that you signed this stuff with to begin with, which is maybe an excess of optimism. I mean, you look at how many times CAs have gone rogue and, how many bad SSL certificates you got out there. And you look at how many times companies have gotten owned badly enough that the attackers got literally everything. You look at how many times companies, fail to properly segment, separate areas of their network and their application stack from one another. And, getting into one place gets you into everything. Then that leads you right back to, okay, what does this really tells us? It tells me that if there was an attacker, the attacker had to get as far as being able to get to the signing keys as well as to the code. Now, is that a worthwhile additional step? Yes. Is it like a guarantee that there's nothing going wrong on the other end? No.
Yeah. It seems mostly it's trying to sell people SGX.
Well, yeah, it's a coincidence, isn't it, that this is coming out of Intel when they are selling the hardware to make it happen.
Right. Although there are similar hardware offerings from all the other big CPU vendors as well.
Yeah, and they do point out that they're going to try and make this hardware agnostic.
Well, yeah, to make it a proper internet protocol, it would have to be not depending on Intel SGX specifically.
Certainly not on the end user end. You could make it a proper internet thing and say you have to be running Intel servers in the data center as long as the client side did. That would still be a stretch and it would suck. And I don't think Intel actually has the muscle to pull that off anymore with as much, Graviton and, all the, not just AMD, there's a lot of competition for the server space right now. But like if this had come about 15 or 20 years ago, I don't think it would have been that hard to say, hey, look, here's this extra security and you have to be running Intel servers, for your Intel hardware on your application servers to take advantage of it. And as long as it still worked for the client end, on whatever random laptop or phone or whatever you happen to be browsing with, I don't think anybody bat an eye. So I guess I'm just glad Intel doesn't have that kind of clout anymore.
Okay, this episode is sponsored by Linode. Go to linode.com/25A and see why Linode has been voted the top infrastructure as a service provider by both G2 and TrustRadius. From their award-winning support offered 24/7, 365 to every level of user, to ease of use and setup, it's clear why developers have been trusting Linode for projects both big and small since 2003. Deploy your entire application stack with Linode's one-click app marketplace, or build it all from scratch and manage everything yourself with supported centralized tools like Terraform. Linode offers great price-to-performance value for all compute instances, including GPUs, as well as block storage, Kubernetes, and their upcoming bare metal release. Linode makes cloud computing fast, simple, and affordable, allowing you to focus on your projects, not your infrastructure. So go to linode.com/25A, create a free account with your Google or GitHub account or your email address, and you'll get $100 in credit. That's linode.com/25A. Intel have announced their 12th gen Core Alder Lake CPUs, and this time it looks relatively interesting from them.
Well, it's certainly different. Intel is embracing the whole big little architecture now. The same thing that you see in smartphones that have performance and efficiency cores, the same thing you see in the Apple M1, which has, the high-performance Firestorm and the lower-performance Ice Storm cores. Intel's doing the same thing with Alder Lake. That has required some fairly significant changes to get made in Windows, which hasn't dealt with as much of that kind of thing as Linux has, since Windows on ARM is like it's a thing, but only sort of kind of. It's not really the same project. I think the thing that confuses a lot of people is why you want, big little on something like a desktop PC. And the answer is that, power is not the only constraint that a big little architecture helps you out with. There's only a certain amount of space on die, and it turns out you can actually pack more lower performance, higher efficiency cores onto the same amount of die space for an overall higher amount of compute power distributed amongst all those cores than if everything was the individually fast high-performance cores. So in the same amount of die space and the same amount of, thermal constraint and everything else, you might be able to have an 8-core, all fast cores processor or a 20-core, big little with lots of littles and only, 4 high-performance cores. And in that case, if you've got massively multi-threaded workloads, you can actually see higher performance in that same limited amount of die space and thermal solution than you would have with the traditional all-in, everything's a fast core design.
How much of that is Intel press releases, though, and how much of it has actually been tested?
Well, at this point, it's all Intel press releases. I've got an Alder Lake system on hand with an i9 in it, but the only thing I've done with it so far is install Windows 11, and if I'd done any more, I couldn't tell you about it yet because the embargo hasn't lifted. It is certainly, it's a well-proven and very reasonable architecture. There's no question about the fact that, yes, you absolutely can pack more processing power onto a single die of limited size with big little than you can with all big. If you have workloads that respond well to, massive multi-threading, where you say, hey, I don't care how fast the individual threads are. What I care about is the aggregate processing power of all these threads on all cores. Actually, your best case then frequently would end up being all efficiency cores. But you don't want that in an interactive system that has users in front of it, because the users are going to want very low latency returns on a lot of single-threaded jobs. So you have a mix. You've got high-performance cores that can give you very rapid returns on, single-thread bottled workloads, and you've got tons of lower efficiency cores that can do a better job on long-running workloads that can be distributed amongst all of them, and also, as a happy bonus, consume less power and generate less heat while they're doing it. But in a desktop constraint, your biggest concern is not so much the power efficiency, which is, what you really care about in the smartphone, where, we first really saw big little reach wide adoptions in smartphones. You want to be able to run long-running tasks as efficiently as you can to get the best battery life that you can. So everybody's already on board with the idea of why they want this in a smartphone and a tablet, and then from there, a laptop. But then the progression to the desktop is where it gets curious. And again, the answer there is just how much can you pack onto one die? And if you have long-running multi-threaded workloads, again, you're better off with the efficiency cores. It's much like the same thing you see with these really, really massively multi-core ARM processors in the data center. The individual cores are not that fast. They're not supposed to be. That's not what those CPUs are designed for. They're designed for very big multi-threaded workloads where what really matters is the sum output of the entire thing.
Well, that was my next question. It seems like Intel are going after that market then as well, or at least could be, with the data center.
Well, we've not seen what the server versions of these are going to be like yet.
I mean, Intel has never not been going for the data center.
Yeah, but what I mean is they're going after the innovations in the data center. They're not just sitting back on their, hugely powerful Xeons necessarily.
If they did, they wouldn't have much lunch left very soon.
Yeah.
With both AMD and ARM companies like the Graviton and the Ultra being at hundreds of cores now, and some of them aren't as slow as we've been talking about. Like, I think the newest Ultras can get as high as 3 gigahertz times 160 cores. Intel really had to do something, I think. And it's interesting to see, like, these i9s have 24 cores because they have 8 performance cores that each have, or so it's not 24 cores, 24 threads, because 8 performance cores each that also have a hyperthread, and then 8 efficiency cores that don't have a hyperthread, giving you 24 threads in total. And although the clock numbers get kind of all over the place because, like, the E cores run at 2.4 gigahertz and can go up to 3.9, but the P cores run at 3.2 gigahertz and can go up to 5.1, except for the one special core can go all the way up to 5.2 gigahertz.
So you're about to benchmark these, Jim. Are you going to do anything different than normal?
I haven't fully evolved my entire benchmarking plan, honestly. The first thing, obviously, is just getting the usual run of performance tests with well understood benchmarks like Cinebench and what have you. That'll tell us a lot about the overall oomph of the processor, but we kind of also need to know answers for the power and thermal efficiency, and doing that is going to get kind of weird, and I'm not sure to what degree I'm going to be able to control what apps run on what cores. I had the same problem when I was testing the M1 when Apple first released the Mac Minis. I was like, how can I actually really test everything that this thing does? And I'm still on the drawing board right now with Alder Lake.
Yeah, I'm thinking, like, with Windows 11, would you be able to use the CPU affinity thing to, like, after you run the benchmark normally once, run it where, like, it's only using the efficiency cores and see, or only the performance cores and see what the differences are?
If I can, I plan to try to. I'm not sure if I can that easily yet. We'll see.
Yeah, a lot of those tools will apply their own settings or using almost like real-time mode or whatever to make sure background stuff in the OS isn't impacting your benchmark score, and it can mess with the normal ways we try to do things like that.
I'm going to be really interested to see the Linux benchmarks for this because, as you said, Linux has kind of already dealt with this problem before, whereas this is relatively new to Windows.
I think what's going to be interesting is to see new types of benchmarks come out that are specifically designed to look at the big little stuff and measure the differences there. Benchmarks that actually understand that it's not just a bunch of cores. It is actually, there's big little happening here.
Yeah, one of the things I do plan on doing, I'm going to try a new benchmark suite. The vendor actually reached out to me offering this thing, and the big claim to fame that the vendor is mentioning is that it's massively cross-platform. You can run the same benchmark suite on everything from Android to iOS to macOS to Windows to Linux to you name it. And I found that incredibly interesting because, yeah, I mean, it's great to say, oh, well, we're comparing, these benchmarks that only run on Windows, that only run on x86 and, feel like you know exactly what you're looking at. And yes, things do get complicated when you cross architectures, and it can be hard to do exact apples to oranges, but you have to be able to make the effort. And I think for a lot of time in particular, people weren't aware of just how powerful, mobile CPUs were in smartphones, because how would you compare? You just assume, well, this thing in my pocket is, it's a bitty box and it's not that powerful. But honestly, for myself, it wasn't until the M1 came out that I realized just how powerful, not just the M1, but even, Qualcomm CPUs. They're not as fast as the M1, but they're legitimately way up into, high performance laptop territory. And I had no idea because you can't run the same software on both architectures.
Same. That's why I was blown away by it. And I was so skeptical until I saw the reviews and everything. And I was like, okay, well, I was wrong then.
When I was first trying to compare ARM to x86, it kind of fell back to a couple of really basic things like, AES GCM encryption or, a SHA-512 hash and a couple of the basic things. But even there you get, oh, well, this ARM CPU has a special instruction for it that makes it faster than an x86. Or it turns out that ARM is faster at AES CBC than AMD 64, but AMD 64 is still a bit faster on AES GCM unless you have a specific extra feature on your ARM v8.3 CPU and so on.
And for those that are interested in that benchmark suite, now this is not an endorsement because I haven't actually tested it and really gotten my hands dirty with it yet. But if the idea of a very cross-platform benchmark suite appeals to you, you can check it out. It's called Crossmark. You can find it at, and I have no idea why this name is what it is, bapco.com, BAPCO.com.
Well, I look forward to your benchmarks, which should be out hopefully shortly after this episode.
Yes. The embargo lifts November 4th, so yeah, you should be seeing those on the 4th or the 5th at the latest. Okay,
this episode is sponsored by CBT Nuggets, training for IT professionals or anyone looking to build IT skills. Go to cbtnuggets.com/25admins and sign up for a 7-day free trial. The on-demand virtual labs mean you can build practical experience with the commands, config, scripts, and everything you need to get the most out of each course. Another standout feature is the accountability coaching service, available to all learners with a subscription, which gives you access to a real person who will help you craft a personalized learning plan and set goals, and will check in with you to keep you accountable. So start your free 7-day trial today at cbtnuggets.com/25admins. It includes unlimited access to all course materials, including virtual labs. That's cbtnuggets.com/25admins. Let's do some free consulting then. But first of all, just a quick thank you to everyone who supports us with PayPal and Patreon. We really do appreciate that. If you want to join those people, you can go to 2.5admins.com/support. And remember, for $5 or more per month on Patreon, you can get an advert-free RSS feed. And if you want to send in your questions or feedback, show@2.5admins.com. Okay, Kevin says, I want to have a solid backup solution for my ZFS pool, but I hear you all say it's not a backup unless you test it. So, how do I test my backup? I have my ZFS pool being sent to a Pi with a USB disk currently. Deleting my pool and restoring from backup as the test feels pretty risky. Are there automated ways to test backups? How often should I test my backups?
Well, if you're doing your backup by way of ZFS replication, it's incredibly easy to check your backup. Literally, all you have to do is a ZFS list tsnap to list all the snapshots on the system, because each snapshot is verified cryptographically all the way down to the block level. And because you cannot have a partial snapshot on a ZFS system, that means if it says the snapshot is there, it's complete, it's good, it's verified, you're done.
And you can mount them and actually go and poke around and make sure your files are actually there, that you back up what you thought you backed up. Nothing worse than backing up the data set and finding out that, oh, this other thing was mounted over top of it, and that's where the files were, and I backed up an empty directory. But for testing, easy thing to do is spin up a VM and restore to it. You don't even have to restore everything. Maybe just pick a small subset of your data or whatever, but just do a test restore to a VM and make sure that your files are there and that you, like Jim was saying, with the snapshot stuff, you can be sure your data is there, but you want to be sure of your ability to get it back the way you need it to be when it's middle of the night and you're under stress, right? Everything you practice means it's less problems later down the road when you're trying to do this in a less than ideal situation. So part of the testing is just testing your own skills and building up that muscle memory of how to go from, all right, there's my backup over there, and here's an empty machine, to I got my stuff back up and running again.
Yeah, and the most bulletproof way to avoid those problems of, am I backing up the right things? Did I get all the stuff? Stop doing work on bare metal. Do all your work on virtual machines, one virtual machine per data set. And if you're doing that, then, when you snapshot that data set, that is the entire virtual machine. You can boot it directly on the remote end. Particularly, I do Linux stuff. Both sides are going to be proper Linux for me. There's no Raspberry Pis involved. It's a Linux x86 box and a Linux x86 box. And if I want to, I can literally just boot any of my VMs directly on the backup host, to click around in there and make sure everything looks good. But I will admit that's something I do considerably less frequently than I used to because, after you've poked at it for a while and, gotten that kind of reptile brain level of assurance that, yes, this means what you think it does. And, then with the, more cerebral part, you say, okay, well, I know that, every single block of this data set is there and every single block of it has been cryptographically verified to be what it's supposed to be. A lot of that need to constantly be trying to put things back into a production status and messing around with them as though they were production kind of goes away. You don't have to do so much of that really ugly kind of verification as you do with traditional, like a tape backup. There's no way around that. If you want to verify that, you really have got to go through that whole process of restoring everything. But when your restoration process is just boot the VM, and it doesn't matter what machine the VM is on, because it's a VM, it's hardware independent. And if you want to, you can boot that VM without doing an actual restore at all. You can just boot it directly from the copy on the remote machine. Life's a whole lot easier.
Okay, Paul says, I'm thinking of replacing an aging Sophos SG hardware appliance with OpenSense. The question is then, what hardware to run it on? The makers of OpenSense sell nice bare metal hardware appliances, but I've also heard of people running their OpenSense installations virtualized, for example using Proxmox. In a business context, what would you recommend running a firewall like OpenSense on?
In general, it depends on your needs. If you have a need for extremely high performance, then virtualizing it's probably not the best answer. But in general, putting your router thing in virtualization is okay, especially if you're using it just for more of the kind of security gateway type applications rather than the actual routing. And it depends a bit if you need some of the hardware actually has a feature that while the thing's rebooting or offline or not working, the switch ports on the front of it can just fail over and still pass some traffic so that your whole network's not down just because your router's down. But sometimes you don't want that. But in general, I think running OpenSense in Proxmox is fine. But if you really want the best performance, most packets per second, then you probably want hardware.
It sounds like really you're talking more about the arguments for a Proxmox VM versus just a generic x86 box with OpenSense on it. I think the biggest thing that you get really out of buying actual OpenSense branded hardware, for one thing, it's really not badly priced at all. I just recently put some in for an enterprise. But another is that, you do again get the full on support, which if you're in a corporate environment can be important to be able to say, hey, we can literally call up the vendor and get support for this.
Yeah, in an enterprise environment, that can make sense.
But am I right in thinking you don't need a ton of horsepower for this? Like even a relatively low-end x86 box would do it, right?
For gigabit, yes. And depending on the number of users in the environment. But if you're talking about like multiple 10 gig interfaces, VLANs, complex routing rules between the VLANs, the whole thing, you may want some fairly significant firepower for that.
Well, and especially like they're replacing this security gateway. And it's like if it's scanning for viruses, all the traffic going back and forth, and if it's doing TLS intercept and getting into more and more complicated stuff, then that's going to keep ratcheting up how much hardware you need. Or even just how big of a VM you need if you're going to do the Proxmox route. But yeah, I think to Jim's point, the advantage with buying the OpenSense specific hardware is bundling it with support and so on, which can be important in an enterprise deployment. But at the same time, yeah, it mostly comes down to how beefy of an OpenSense machine you need, which makes more sense. But there's not too much downside to just virtualizing it. Just don't get in a situation where you can't reach the management interface for the hypervisor without the router.
Fun times.
It is always interesting to run some of the critical stuff inside the VMs because then it's like, how do you get to things?
Right. Like when your SSH jump host is a VM and you have a problem on the host. Oops.
Or, when people are doing, some kind of virtualized ZFS to be the backing sort for all the other VMs. It's like, well, this VM definitely has to come up first.
Oh, I hate that.
Like, don't do that.
I hate that so much.
ZFS wants real hard drives. Stop screwing around.
I can't believe you managed to shoehorn ZFS into this question, Alan.
It's what he does.
Literally, I'm just thinking of the arguments I've had this week with people about virtualizing their ZFS.
Honestly, this was less of a stretch than last time he shoehorned it in onto an episode that I thought we were going to get all the way through without mentioning ZFS, and Alan just suddenly starts off on a ZFS anecdote. I'm just like, damn it, Alan. We almost made it.
Sometimes when you have a hammer in your hand, every problem looks like a nail.
Right, well, we better get out of here then. Remember, show@2.5admins.com for your feedback and questions. You can find me on Twitter @Joe Ressington.
I'm @JRSSNet.
And I'm @Alan Jude.
We'll see you next week.